Okay, so now it's a 0 through 9 pattern, and if you want to know, okay, any number that ends with 0, 0 will be zero's prime. Any number that ends in 1 will be 1's prime. So for example, if you say 741, that'll belong to the 1's category because the last digit ends in 1. Because for infinity, you'll have everyone's numbers that go. So you'll have 21, 22, or or whatever, 22. It usually be in this. Sorry, my phone. But this is also the answer to the Riemann hypothesis. Like every one of these zeros will land on this line, except for when you get to 100. Oh, sorry, my phone. So for when you get to 100. 101 is off the line, the 0 is. But for every 10th, it'll be on line for infinity. But so anyways, you go over 102, 103, 104, 105, 106, and to 109. So let's put 109. And so if you start your pattern back down, now you're here, 110. And then you go back down to 120. But if you're in your circle pattern, you still be. But if you noticed, it's what you start off with, your 0 through 9 circle pattern. But this way, every number has a home. Like, and how you tell what home it goes to is its last digit. So like, if you're say if we say 100,777, that means 7. The numbers before the 7 is how many laps that 7 had to make to get there. So you pretty much any number you can know its prime or where it originated from. It gives every number a place to go. Because for infinity, you'll have every number that ends with 2. For infinity, every number that ends with 3, every number that ends with 4, every number that ends with 5, 6, 7, 8, 9. You have any number for infinity. So you'll have your 10 lines, and using 0 as your starting point and your balancing point, you got 10 numbers right there. So it's a 5-5 split, so evenly there. But every number will have its spot for it. But you can tell any prime by the simple fact just the last digit of the number. So the last digit of any number will connect you to what prime it is by the 0 through 9. So if it ends with the 1, no matter what the number is, the last digit, if it ends with the 1, it belongs to the 1 category. And that just means it had to make that many. The numbers before it, the 1, were just how many laps it had to make to get there. But so that answers also the Riemann hypothesis, because I got every number. So primes are really not, like, every number has a prime, and there is no spot where a number don't hit, because every number belongs to a category this way. I don't know, so, but you just keep going around like that's this one's kind of shitty. But yeah, so you just go 0 through 9. So 0, 1, 2, 3. Oh sure, I didn't make a very good circle there. 4. The 5's above the 0. 6, 7, 8, 9. That'd be like your first ring. So make that your first ring or whatever. So whatever, you don't get confused. And then your next one, you got your, so you're below your 0 will always be your 20, 30, 40, 50, all the way down for infinity. It just keeps getting bigger. But there's so many patterns in it. Like if you notice like right here, look, if you ignore the zeros, it goes 1, 2, 3, 4, 5, 6. It'll do that all the way to 1,000 before it resets. And then, but yeah, this way I don't see if anybody's even saying anything. Anyways. But yeah, that's how you can know all that good crap.